So, hello everyone. Welcome to the DP Tech. So, in this video, I'm going to explain you about in a .NET technology using C Sharp language, how the source code converted by the compiling environment to machine code, or we can say managed code. So, this is the diagram that I prepared, and I'm trying to explain you about all the components uh, which uh, which performed during the compiling phase, or I can say all the process has been happening uh, throughout in the CLR process. So first step is a source code. Source code is nothing just like uh, I can say a code which is totally written by developers. So suppose, for example, in our case, the source code is, for example, we can take abc.cs. CS is the extension of C sharp, because in this diagram I'm explaining all about the process of compiling things as per C sharp compiler. So abc.cs is a source file. Source file is nothing like a program file where you have wrote your own logic. Second step is a compiler. As we know, the CLR is a compiling environment, and all the component which in the screen you're able to see it are part of the CLR. So in that process, there is a, because we are using a C sharp language, obvious that the compiler will be CSC. So that is a C sharp compiler. Now that C sharp compiler has a responsibility to convert only the IL code instead of managed code. So that compiler, that individual compiler are not responsible to convert into the machine code. It's just responsible to convert that IL code. That IL code is a common language that understand or compiled by JIT. So for that purpose, why we are converting, and why .NET choose that kind of a process, because as we know, .NET framework support multiple languages, and each and every languages had its own compiler, and own compiler based on their syntax, based on their programming structure, based on their uses. So we can't change the compiler behavior and the compiler process things, but we change a little bit about uh, compiling end result, I can say. So every compiler as it is we will use in the .NET framework for each and every languages, but only we will change and modify only that part. The compiler is not responsible to generate the managed code, it's only responsible to generate that IL code. So that is a IL code, it's an intermediate language code. That is a very common language for all .NET languages which is supported by .NET. So each and every languages that is supported by .NET are ultimately uh, create a IL code, IL language, I can say, plus the metadata. Metadata is nothing about data. About data is called metadata in a general language, we can say. So in this, after compiling process, it will generate the IL code and the metadata. Then after there is a CLR process will execute it, and the CLR process we have lots of its component like GC, CTS, CLS, and CS. GC is nothing, is a garbage collector. uh, as we know, garbage collector is very important part of compiling process, because in a compiling, in the programming development life cycles, we are creating an object, we are declaring a variable, we are instantiate multiple things, but we are not managing the memory and utilization of that resources. So that garbage collector is a feature that CISA will provide you. You are not worry about that memory management, that GC will all take care of that part. So for that purpose they are using garbage collector. The second check the CLR will perform like CTS. CTS is a common type system. Okay, the CTS is nothing like a because as we know, the .NET supports multiple languages, and we are using CSC, that is a C sharp language, and that CTS is just checking. and applying the rules. What types of rules? Because it's about type. So as we know, different languages having a different syntax. Suppose for example, in a Visual Basic, we wrote integer as a complete integer. In the C sharp, we wrote integer as int. In a C++, we wrote integer data type as int. So different languages having a different structure of or syntax of writing that program or using that data. But the C sharp or CLR will understand only those type which is commonly defined in that CTS as per their rules. So it's check that is that type is commonly satisfied that rule or not. So if Visual Basic integer come to that CLR process in using that CTS, it just validate, okay, that is an integer. In C sharp, that is a int, but ultimately that integer and int just uh, consider as a int 32 for that CTS. So for CTS, both are is a int 32. So that kind of a check, that kind of a rules applied and validate is that type compatibility or not in for that particular languages. So that is that kind of a check happen that CLR process. The second thing is checking CLS, that is a language specification. As we know, because of that CLS, we are uh, able to use multiple languages in .NET, because that CLS will specify and apply that rule that we can able to achieve multiple languages supported. The second is a code access security. Code access security, as name already defined that meaning. Uh, as we know, in our operating system, whatever the code, whatever the exe file you will execute, every time you should have uh, get access and allow that access to that particular software or tools need to be executed. So that accessibility of execution permission we need to perform, then after you will execute that particular exe. For instance, whenever you trying to install few of the software component in operating system, every time when we execute that setup, the operating system will ask you and for a permission. Immediately a pop-up will appear on the screen, and they will ask for authentication. Can you this software is authorized to execute, yes or no? When you click yes, then the exe will get executed, and whatever the step need to be followed for installation process, you can follow and do the installation. So that kind of security tech need to be there, because this is a C sharp program, and that program ultimately create a exe file, and that exe file need to be secure. That purpose, that CS component get executed, and it's validate all the things. In that duration, in that process, all the performance, it will generate one file that is called manifest file, this manifest file. So in this manifest file, why we are generating? Because all the resources, all the components required a space, memory space, right? At runtime, only one resource is available in the operating system, where that provide you a runtime memory, that is called RAM, right? So the RAM provide you the memory, so that you will inform RAM what are the resources, what are the references, what are the public token key, what are the version you are going to be executed on that operating system. So those kind of information need to be provided to the RAM, so that RAM will aware about that, what kind of files get executed, and what kind of resource is required to execute that file. So that kind of information we are going to be provided to RAM in the form of manifest file. So in this manifest file, generally we have that multiple informations. I put in on major four information, like assembly version. Assembly version is nothing like a version of .NET framework, which version you are going to execute on that operating system, or in which version that exe will compiled. So for instance, if that exe will generated using .NET 4.5, so RAM will check in the operating system that is that .NET 4.5 is installed or not. If not, based on that assembly version information, it will immediately pop up a message, because .NET 4.5 is not installed on your operating system, you can't run this applications. So how that RAM or how that or your operating system will get to know that which type of system or which type of component needed to execute that particular file. So, yeah, right. So that kind of informations we will available as a manifest file, uh, and that assembly version is related to that particular things. Second is public token key. As we know, each and every program or each and every component considered as a unique key. So RAM should have contain each and every execution, each and every things as a unique key need to be maintained. For that purpose, a public token is generated and that is kept on the manifest file for RAM. The third one is resources. As we know, a different application having a different kind of requirements. For instance, if we develop a console based application, I mean to say a command based applications where we are displaying message on command prompt. So that kind of a program we are going to be developed or we will develop. So in that situation, what types of tools we needed from operating system? We need a CMD, because without that CMD we can't execute, we can't get input and output through our program. So that kind of resources we needed. So that information need to be available in RAM. So that is maintained in manifest file as a resource. The fourth one is related to the reference. So reference in this reference is just a kind of a anything or any files or any kind of a particular thing that need to be linked using your program. For instance, if you are doing some IO operations through your program to write some data into the file or read some data from the file, so that kind of operations you required. So that means you are reading data from the file on a particular location. That means RAM should know and aware about that part. Okay, that is a D drive, and that D drive there is a file ABC, and that file need to be read by this program. So that kind of reference need to be available, then you will able to read that particular file. So that kind of information generally maintained, so that the process will generate the manifest file, and manifest file contain these four important information about that program. And in that durations, when the IL code and all kind of checks has been completed, then after the role plays a very important part is called JIT. Actually JIT is a compiler which are responsible to generate the managed code. So JIT is nothing, just a compiler. That JIT understand only IL code. JIT don't understand that source code. It only understand the IL code, intermediate language. In the full form, I can say Microsoft Intermediate Language. We can say, but in the short form, we can also say IL code, intermediate language. So JIT understand only IL code, and after JIT, convert that IL code to managed code. Managed code is nothing that a code generated by the CLR process is called managed code, as in a simple languages, because that managed code terms uh, come out when we are processing or when we are generating a code through CLR process. So that managed code generally comes from that process only. So if anybody can ask you what is managed code, so simply you can say if the code or source code will be generated through the process of CLR, that means that code is a managed code. That is a simple definition. In the JIT process, as you can see, there is a three major component I included here. The first one is a pre-compiled JIT, the second one is a economical JIT, and the third one is a normal JIT. Why we mention that? Because the process of JIT, as we know, is very fast. Why we are fast? Why that JIT process very fast? Because of these three components. The first component is referring the pre-compiled JIT. Pre-compiled JIT is nothing, just a process where we compile the IL code from top to bottom in the first time, in the first approach. So there is a first time we are going to be compile that file. That means there is no any existence of that IL languages in the memory. So that means we are going to compile from top to bottom. So in that case, JIT will perform that pre-compiled JIT. In the second time, suppose that program is already compiled and IL is already generated and JIT already compiled that thing. The few of the things are already available. Now we are just using some some I can say a library to compute something, like we are using math library where we are using some square root or cube, that kind of a functions we are using in our program. So that function is available in the form of library, and that is already compiled. But uh, it is available once we are using it. So that kind of a process, if we are using that math.square, then we are going to be load that math.square. We are not unnecessarily load those library which are not in use. So that purpose, if that math library a square root are going to be used in that section, then it compile that particular method and release that resource immediately. It not consume for the next time process. You just compile it, provide to that program, calculate and everything, and then after release that resources. That releasing part only include in the normal JIT. Everything will be same, but the releasing part is not there in the normal JIT. It will also compile the existing or we can say a runtime methods which are available or which are required uh, to use or used in the program language in a program. So in that durations, that method came out and compiled successfully, and then after it will consumed by in a memory itself. I mean to say, cache it, so that in a next process that method is available in the memory. They are not going to be call it from the source locations for that so that the process become more faster. Instead of going to the source location, that method is available in the memory itself. So obvious that the process will get fast. Okay, so that kind of three component executed inside that JIT process, so that the compilation process become faster. Okay, so now when all the process has been generated, there is a ultimately we are generating we are generating a DLL or exe. Exe, it means the executable file, or DLL, it means the dynamic link library files. So two types of file generate we are generating, a library or a exe file. Library means we are just utilizing that particular things, we are not going to execute it. So that kind of a file or that kind of a program is called library files. Exe, it means it is executable files. Anyhow, we can just double click on that and it will execute the application. So that kind of a file is called exe file. In that duration, there is one file is also generated that is called pe files, that is called pre-executable files, that is also generated. And it's not nothing, it's exe files. During that process it will generate. So this is all about how the source code converted to the machine code in a .NET framework technology. So yeah, that's it for the that process. In a later video, I will come with more .NET content. Thank you.